Okay, so this is a story of how morphological and molecular studies were combined to produce a robust taxonomic definition or description. And this is my outline. I would like to, I've already given you my acknowledgements, and then in my introduction, I will be discussing the discovery of the ant and the morphological study. And then later, the molecular studies that strengthen the hypothesis that this is actually a new genus. Then we'll show you the taxonomy, the pictures, all the pictures that I've taken, many pictures, not all of them, of the different ants that belong to this new genus. A short discussion, some recommendations, conclusion, and references. So this genus was first identified by myself in 2003, based on a unique specimen from Mount Isarog, collected at 1,550 meters above sea level. Unique meaning it's the only one that we were able to collect. Wala nang ibang kasama. And it keyed out to a genus called Lordomyrma in Bolton 1994. Bolton 1994 is the gold standard key for ant genera of the world generally. And it keyed out to Lordomyrma. But it doesn't look like Lordomyrma. And I'll show you that later. So because of our discussions with the people at Harvard, they eventually gave up trying to figure out the ant. And they said, do you have a visa to the US? He said, yes. Okay, we'll send you a ticket. So because of the one ant that we collected, the unique ant from Mount Isarog, I was given a round-trip ticket to bring the one ant to Harvard University. And what is that one ant? Ito. So this was imaged as soon as I arrived. I was still shaky from the trip. They were so excited, they mounted the ant and then started imaging and started analyzing. Yeah, it's just another ant, but I'll come to that later. And in 2004, since they couldn't figure out in the MCZ what genus this was, they asked Barry Bolton, who is the guy who wrote the Bolton 1994, what his opinion was. And he said, oh, it looks like Lordomyrma. Maybe. So he only opined. He only gave an opinion that it's probably Lordomyrma. Going back to his key, kasi yun ang nag-key out. We were stuck at that point because it was only an opinion and there's only one ant. Nothing more to do about it. So, buti na lang, may ibang nag-aaral ng molecular. And, oops, in 2009, this guy, Eli Sarnat, extracted the DNA from that ant and showed in their paper that it was not Lordomyrma. I will show you the tree where it is actually outside of all the Lordomyrma that they analyzed. And in their study, they analyzed it as genus undetermined PH03. So that means PH Philippines and then 3 undetermined genera from the Philippines. So hindi pa nila alam anong ID nun. They just call it undetermined. Playing safe. They use 3 nuclear protein coding genes. I always strip reading those things, so I'll let you read it silently. Nabubulol ako dyan. Okay, and the 3 is this one. Now, in this 3, notice what is in the red box is the genus undetermined PH03. And you follow that, it is sister to or outside of this whole group of grade names, which are all Lordomyrma. So in their study, using 3 nuclear genes and 1 ribosomal gene, nailabas na nila yung genus undetermined PH03 from Lordomyrma. Now, I also put a yellow box there because these are 2, at that time, undescribed Lordomyrma species. Now they have been described. PH01 has been given the name Idjanale, Lordomyrma idjanale. And PH02 has been given the name Lordomyrma diwata by Taylor in 2012. We have the types in the National Museum and also in the Museum of Natural History of these two species. Actually, 4 Lordomirma species were described from the Philippines, 3 from Mount Isaropan. So that means there are also so many Lordomirma around. We have to look. Okay, so in this 3, Lucky and Sarnat have effectively shown that my ant, or this ant, is not Lordomirma. Unfortunately, that unique specimen was lost. Mahabang kwento. Ang sabi ni Taylor, who borrowed that specimen, he was about to mail the specimen back to us in the Philippines, and he put it in his laptop bag. He stopped by a store to buy something on the way to the post office. Pagbalik niya, basag yung bintana ng kotse niya, ninakaw yung laptop. Natangay yung langgam ko. Imagine. Who can think of these scenarios? But it has to be true. Unfortunately naman, this guy, Perry Benavente, collected workers of a different species in 2010. Then, Ward naman had the opportunity to extract DNA, and in this study, they used the name Myrmicine genus number 26 PHO2. Again, just code names referring to this genus. Now, this time they used 11 nuclear genes plus 2 ribosomal genes, including 2 ribosomal genes. So 11 genes all in all. Dati 4 genes, ngayon 11 genes. And what tree did they develop? Okay, so in that blue box, yung sinabi ko kanina, Myrmicine genus 26 PHO2. Okay. And wala dito sa clade niya, this group, yung Lordomirma. Okay. But what is interesting here is that they group together 2 other genera, Volenovia and Calyptomyrmex, together with Myrmicine genus in this small clade. Right? We will look at all these genera later. And the red dots here refer to Bayesian posterior probability 1.00 and maximum likelihood greater than 90%. So this is very, very strong support that this genus is different from either Volenovia and Calyptomyrmex and is in fact a good genus. So when Ward informed me that I should go ahead and describe it because he has very strong support. So now I have molecular support, and I'll show you this is the voucher of what they extracted. One of the ants that Perry collected from Mount Palali. It looks similar to the first one, right? I'll show you them together side by side. You will see that they are actually similar. There are differences, although. So, the timeline for taxonomic description is this. Yung Clausi, the first specimen that's ever collected, was discovered in 2003. Lucky and Sarnat extracted the DNA, and then it was lost by Taylor, but fortunately rediscovered in Mount Bulusan by Ron Klaus. And then yung kay Buenavente, he discovered it in 2010 on Mount Palali. 2013 extracted yung DNA and analyzed, and na-published in Ward et al. 2015. That leads to now the taxonomic description of the genus. Okay. And this is the first page of the paper where I published the description of that new genus. I called it Aretidris. Genus Aretidris, General 2015, is derived from 2 Greek names or Greek words, arete, ancient Greek for excellence, and then idris, which is a common postscript, common name for ants, for Greek. So I have combined 2 Greek words to produce Aretidris. Okay, so what are the morphological features of Aretidris? You have number 1, mandibles with long, narrow basal stem. This was the first clue that I saw na ibang-iba talaga itong ant ito. Because not very many ants have this long stem. Oops. And then they have this thickened part of the genna, the cheek. There's a longitudinal ridge. Clearly that is for strengthening the structure of the head that holds the mandibles. So may reinforcement. Aside from that, yung labrum is clearly visible behind or below the anterior clival margin. That is also a rare condition in ants because the labrum is usually folds over under the head like that. Pero dito naka-uslit. Ang pagkakaintindi ko nito is that this structure helps in holding the prey, whatever the prey is. I don't know what the prey is. We don't know yet. Okay, so that's the head. How about the rest of the body? We have a thickening again of the anterior margin of the catepisternum. So it's thickened. Bihira din makita yan in many ants. There's a convex propodium. See that outline? And armed with the reduced spines or denticles. In many myrmicine ants, may spine dyan, may tooth at this corner here. Here it's reduced to a denticle. And the petiole is sessile. Ibig sabihin ng sessile, maikli yung stem niya dito or peduncle, maikli or wala yung peduncle. So in this case, I interpret it as having no peduncle. I call it sessile. Finally, there's a tooth right above the spiracle here, anterior and above that spiracle. Ito is spiracle. This is the tooth. It's not so clear in this picture. But again, this was another clue that told me it was different. And this was a subject of a lot of discussion with the MCC guys before they said, okay, just come over and bring the hand. Yeah, because of this tooth. Because not too many ants possess a tooth above the anterior, above the spiracle there. Okay, so these are the two species of ants. Buenaventii on the left, from Palali, and Clausi on the right, from Mount Bulusan. This was the recent collection of Mount Bulusan. Every time I look at these pictures of Clausi, I kick myself because I was sitting 2 meters away from Ron Klaus on the forest floor. And he announced to me, Dave, I found some ants. And I just said, throw them in the vial and look at them later. And of course, they were Clausi. So I went back to that original site the next day, found no more ants. Ron Klaus found 5, I didn't find any. So I never actually saw these ants running around live. I've only seen the dried specimens. Okay, so this is a close-up of the anterior head of Buenaventii and Clausi, just to show you how similar they are. But in the lateral aspect, you can see that they're also very different. One is very smooth and shiny. One is very rough and sculptured. You might also see that the first segment here is small relative to the gaster. Here it takes up almost the entire gaster. Now on close-up, ganun din. Here you'll see clearly the denticle, the little denticle there. Here, because of the sculpture, it's hard to see. And on dorsal aspect, ganyan naman itsura nila. Buenaventii is actually larger than Clausi. Buenaventii is about 5.7 millimeters. Clausi is about 4.6 millimeters. So 1 millimeter difference. These are the type localities of Buenaventii and Clausi. Clausi was collected here in Bulusan, and the original record is here, Mount Isaru. And then here naman is Buenaventii. Notice the large areas of high elevation na hindi pa siya reported, even Mindoro. So medyo may opportunity siguro to find more species. Now, I was telling you about Lordomirma. These are the two genera put together, side by side. On the top is, on the top is Aretidris, and here is Lordomirma diwata. One of those that was sequenced by Sarnat and Malaki and Sarnat. Okay, according to Bolton, Aretidris would have been Lordomirma because of this bicarinate Clypeus, which also Lordomirma possesses. It's probably not too clear there. Maybe if we can turn on this light, turn off this light. Napapatay ko. Yeah. So this one also has a bicarinate Clypeus. Pero when we look at the lateral aspect, mas malaki yung bukol ng Probisonottum. It's more convex in the Lordomirma than in Aretidris. Plus, very clearly, in Lordomirma, there is this antennal, what did I forget? No, not scape. Groove, yes. Actually, it is the, nakalimutan din yung pero. Well, this structure here is very commonly found in Lordomirma. There is a aberrant form, yung nilipat nila sa Lordomirma only because of the molecular evidence. But it doesn't have that either. Scroll. This is the antennal scroll. Yes. Tapos, tignan nyo yung spine. Dito wala, dito meron. Lordomirma, palaging merong spine. And if you look at the tooth here, it's not present here actually. And there are so many other differences, but let's go forward. So this is a new study, 2017, where they used even more genes and they studied the ultra-conserved elements. So Brandstetter and et al., 2017. They wound up with the same clade, Calyptomyrmex, Aretidris, and Vollenhovia. And with even stronger support, 100%, 100%. Hiwa-hiwalay talaga sila. But this small clade here, we will look at closely this time. So we will compare Aretidris and Vollenhovia first. By size, ang Vollenhovia is about half the size of this one. So itong mga 2.5 millimeters, yung 1 millimeter yung bar niya. This is about 4.6 millimeters. So meron din siyang bicarinate Clypeus as Lordomirma. But almost nothing else is similar, di ba? If you look closely at the petiole and post-petiole, or petiole and propodium, may similarities tayo nakikita. You have the sessile petiole, you have the tooth, they also have a tooth here, and then you have that convex propodium. Pero yung placement na spiracle is different. Right? May identical siya dito, dito wala. Okay lang, that's small. But here, there's a subpetular process. Ang laki. Dito wala. So, it breaks down talaga. Hindi talaga sila magkapareho. So, Vollenhovia is not the same as Aretidris. Now, let's look at Calyptomyrmex, which is the other part of the clade. Actually, at this point, I failed to find any morphological similarity between these two genera. Even though sa molecular, they're supposed to be closely related, there's nothing similar between these two. Even by inspection. Just look at the hairs, clavate hairs dito sa baba. Dito halos walang hairs, straight pa. Smooth, this one is sculptured. So many things. So we have that antennal scroll very deep, dito wala. Okay. So now we have some discussion. Aretidris has been found only at high elevations and only in Luzon. On Palali, this elevation, Bulusan, and Isarog. They have not been found on the lower elevations of those mountains. And then at these other mountains naman, Adams, Cuernos de Negros, Montalingahan, Balatukan, Magdiwata, Apo, and Hamigitan. We know very little about the biology of this genus, and only from collection data do we know that they nest in rotten wood, they forage in leaf litter, and there is one prey item that we found, a male Phaidoli ant. That was also in the Buenaventii nest collection. Now this genus has potential use as a study species or a bioindicator species because they are restricted to high elevations. Then they may show sensitivity to changes in temperature. Why are they restricted to high temperatures? They might need the temperature up there, or the cooler temperature. And if global warming really occurs, then as it gets warmer, they will be forced upward, higher and higher elevation. My recommendations include other mountains need to be surveyed. If you notice that list, it's a very short list. It's not close to being complete. So other mountains need to be surveyed with proper ant collecting techniques. Conservation of forests must go hand in hand with surveys, more field work. And on a practical basis, dead wood, which provides nesting sites, should be allowed to stay on the forest floor, to rot and become habitat. In conclusion, molecular studies supported the morphological hypothesis of a new genus, and that montane forests need to be conserved and surveyed with proper techniques so we can find more species of this endemic Philippine genus.